Today I'm taking a look at the various types of rotary hand tools that would be useful to scale modeling. Originally the video started out just to answer the specific questions I get about what's the handpiece that modelers see me use in the other videos that I've created. Sometimes the questions are just about the handpiece, and sometimes they're an aside. But in any case, it does seem to get people's attention. What modelers seem to be looking for is something to replace this bulky Dremel. When I've answered the questions in the past by email, I've always been very specific. I use a dental lab handpiece, but the problem is what I'm using is very expensive, and it really isn't my favorite. So I thought I'd take a look at some of the alternatives and what might be the best choice for most modelers. First off, as a modeler, what am I looking for in a motorized handpiece? Well, I'd want something that was easy to handle and maneuverable. Second, I need to have a variable speed foot controller. The speed should be able to be slowed way down and still maintain sufficient torque so I can cut through plastic without melting the plastic around the burr. Third, it would be ideal if the chuck could handle a variety of drill sizes. We could probably add in how it fits on our bench, or cost, or maybe some other factors. But for me, those first three things would rate the highest. First off, let's take a look at the Dremel. It seems to be the most common choice for hobbyists, and it's been around forever. It's relatively cheap and available, but it's big and it's heavy. Like a lot of inexpensive rotary hand tools, they function at higher RPMs, and when you get them slowed down, they don't have any torque. So big, heavy, and fast aren't exactly desirable when working around small pieces of styrene or resin. Dremel tries to address the size and maneuverability issue by offering a flexible drive shaft. However, the flexibility is still limited. To make the conversion, the shaft cover, collet nut, and collet are removed. A hex driver nut is screwed on the tool shaft. The flexible shaft is then attached to the motor, and the collet and nut are replaced on the handpiece. They also offer a small 3-jaw chuck to replace their standard collets. One final point about the Dremel. It's squarely aimed at the hobbyist, and when compared with other options, it just has a hobby build and feel. So if you want something with more precision, you'll need to look for something different. The next step up would be one of the Fordham flex shaft tools. These tools offer much lower usable speeds in a more maneuverable handpiece. The unit's operated by a foot control, and you have a choice of several different motors, but I'd recommend the more powerful TX. Fordham also offers a variety of handpieces, including one with a 3-jaw chuck. Fordham tools are extremely popular with jewelers, and I think they're a very good choice for a hobby, especially when you consider cost. So you're saying, why don't you use one? Well, I've tried them, but keep in mind my history with handpieces. It gives me a different perspective. I'm a dentist, and I work with these type of tools all day long, so ergonomics are extremely important. I find the flexible shaft of the Fordham a bit stiff, and I can definitely feel the shaft movement through the handpiece. Also, Fordham works best in their hanging mount, and that can be a bit awkward depending on your work area. When you think about professions most linked with precision handpieces, you obviously have to think about dentists. The original dental handpieces were slow-speed belt-driven types. They're often referred to as dental engines. Later, these belt-driven handpieces were replaced at the chair by high-speed air-driven handpieces. However, they're still used in the dental lab. This type of handpiece is my favorite. You can see how much smaller the handpiece is when compared to the Dremel. And despite the appearance, the handpiece and arm are quite well balanced and flexible. The large engine provides a great amount of torque and can be throttled way down to a crawl. Belt-driven handpieces have a draw collet that's tightened by a screw at the back. All slow-speed handpieces use a 3/32 collet. The pulley and screw in the back make for a convenient lock when using a drill adapter. The best of the best belt-driven handpieces are manufactured by Wells. They use an extremely substantial foot control with a built-in reversing switch. While the Wells is a pricey unit, it's a lifetime investment. However, you can sometimes find them on eBay as a substantial number of dental labs have closed because a fair amount of lab work is moving south to Mexico or overseas to China. Also, there's an increased use of in-house CAD/CAM systems. If your shop is equipped with a tank compressor, you might find that an air-driven slow-speed handpiece would be a good choice. Not to be confused with the high-speed handpieces that the dentist uses to grind your tooth down. The air-driven slow-speed handpieces are basically a scaled-down version of a typical air-operated shop tool. They use the same 3/32 size collet, but can be fitted with different heads to accommodate various contra angles that use either small high-speed burrs or latch-type burrs. My favorite of these is this old Midwest handpiece that has a draw collet similar to the Wells and a button lock for changing burrs. If you decide to go with an air-driven handpiece, you need to have a very good filter. Moisture is the worst enemy of a turbine. You also need an air regulator set about 40 pounds and a foot controller. The entire setup for an air-driven handpiece is the least expensive of the dental options. The latest development in handpieces are the direct drive micromotor type. They use a small electronically controlled DC motor in the handpiece. These units can either be brush or brushless types. The brushless types are more sophisticated and don't have the maintenance or spark issues typically associated with a brush type motor, say like what you'd find in a cordless drill. This is the type of handpiece that I'm currently using at home in my shop. Previously I was using a Wells handpiece, but the arm doesn't quite fit in the compact arrangement of my current bench. So here's a case where fit's an issue. When I built my current workbench, I wanted it wide enough to accommodate all the things that I use frequently, as well as my electrical. I also wanted to have even lighting, because even though I have a task light here, it's hard on my eyes when there's a black hole in the back. So I installed color balanced fluorescence under here, but the valance had to be low enough so that it wouldn't cast a glare in my eyes when I'm working, and that pretty much eliminated the use of the Wells with the long arm. Like any tool, they can range in quality and price. The one I use is manufactured by Osada out of Japan, and it's typically rated as one of the best. However, even companies like Fordham now manufacture these type of handpieces. Here's the electronic control unit for the handpiece. It controls the speed range and the direction. I have everything wired through the bench to keep it out of the way. Since it's attached with just a lightweight cord, it's extremely maneuverable. The handpiece is ridiculously smooth and quiet. If you didn't see the burr turning, you wouldn't even know it's running. It's amazingly powerful, especially given the size of the motor. And for what it was intended to be used for in the dental lab, where we only use burrs and mandrels of just one size, it's just flat out the best tool. However, after using one for a few years for scale modeling, I would have to say they have a few drawbacks. They can't be slowed down as much as the Wells and still maintain an acceptable torque. Second, all these come with a handpiece that has a quick change collet. That works well when you're only using typical lab burrs and mandrels, but when you want to use a miniature drill chuck adapter, You have to be more creative when you're tightening the drill chuck. So to wrap things up, the editor's best choice goes to the Fordham TX with the 3-jaw chuck handpiece. Cost not being any factor, the top tool has to go to the wells. I hope you found this video informative. And so long for now, and I hope to see you next time.